What's going on, everybody? Today we're going to be going over 8.5b, which is atomic identity. Identify that protons determine an element's identity and valence electrons determine its reactivity. So we're going to talk about a couple of those things today. I'm going to show you some stuff on the board. Hopefully it helps. Sorry, excuse me. Allergies, my bad. All right, so this is a little bit of a review. Let's look at carbon on the periodic table. It is number 6. So I'm going to do the symbol of carbon. It is number 6. So remember that if it is number 6, we know that the atomic number is 6. So that number tells us how many protons it has and how many electrons it has. That you need to understand that fully at this point. Okay, so I'm going to go ahead and erase that. And we're going to move on and do some other things here. So let's continue to look at carbon. And I'm going to draw the box of carbon here. I'm going to draw the symbol. I'm going to put 6 here and 12 here. Yes. So let's look at this really quickly. We see a 6 and a 12. We need to understand what's going on in this box. We know that this 6 here is going to be the atomic number, and we know that this here is going to be the mass. And so we need to know that if the mass is 12 and it has 6 protons, how many neutrons does it have? Well, there's the strategy that we have M minus A equals N. So the mass, which in this case is 12, minus the atomic number, which is 6, gives us 6 as the neutrons. So we know in the atom's nucleus, so I'm going to go ahead and draw that now. This is just for drawing purposes. We have 6, 1, 2, 3, 4, 5, 6 protons. And we also have 1, 2, 3, 4, 5, and 6 neutrons. Okay? That's inside the nucleus of our atom. All right, so a little bit of that is review at this point. So now we need to, we're now going to draw a Bohr diagram so we can understand this stuff a little bit better. Let's do magnesium, number 12 on the periodic table. So at this point, here's what I'm going to do. I'm going to draw my nucleus, and I'm going to say, I'm going to do a little information in my head here. I'm going to look at it. It's number 12 on the periodic table. It's in group 2, right here. Mg, so I'm just going to put Mg just for identity purposes right there. And it says it has the atomic number is 12 and the mass is 24 because we round. So 24 minus 12 is, that's right, it is 12. So we know in my nucleus now, I have protons equal 12. And I have neutrons equaling 12. For a total of 24, that's my mass. Okay? So now I'm going to draw some orbitals. And it's in row 3. So I have 3 orbitals that I have to draw. 2 and 3. Don't be confused with the nucleus. The nucleus is what it is. There's 3 orbitals here. There's a rule of 288. And this information is coming soon. I'll be doing a video on breaking down the periodic table. This is just to give you some information. So 288. What that means is the first two let's go with blue. Electrons are going to go in the first orbital. The first orbital cannot hold any more electrons, so up to 8 need to go in the second orbital. 1, 2, 3, 4, 5, 6, 7, and 8 for a total of 10. How many electrons does magnesium have? If you were to ape it out, what would you find? Well, atomic number is 12, so we know that it has 12 protons and it also has 12 electrons. We've drawn 10 so far because 2 plus 8 is 10, and this one has 12, so I have 2 more electrons I have to do, so they will spill out onto the next orbital. That is a Bohr diagram for magnesium. Okay? There's a good example, so you can use this video going forward for that. The last thing I want to go over is how the periodic table is organized. Okay? So I'm going to pull this up a little bit just to get a little closer so we can look at this here. What I would do if I were you is definitely look at your periodic table so it makes sense. I'm going to get this out of the way, and here we go. So as we're looking at our periodic table here, we see, actually, let me pull that even closer. We'll just look at it like this. We have these columns that go down, also called GFC. It's columns, families, and groups. It's the same name. You know how, house, home. It's like things have the same name or have different names, but the same thing. So they can be identified as being called columns or groups or families, but it's the part that goes up and down on the periodic table. So you can see the number 1 here, the hydrogen group. That is group 1. And number 2 here next to it is group 2. And then we skip this whole area here. These are the transition metals. We're not going to worry about those. But we're going to look at group 3, group 4, 5, 6, 7, and 8. Group 8 is the noble gases. Okay? Whatever group it's in, it tells you how many valence electrons it has. And valence electrons are the electrons in the outer orbital. So if we go back to that drawing I did just a minute ago with magnesium, how many electrons were in that outer orbital? 2. And guess what group it's in? Group 2. So beryllium also has 2 valence electrons. So let's take a look. I'll draw beryllium. Beryllium, Be. Beryllium is number 4 on the periodic table. So we know that it has 4 protons. But its mass is 9. So let's do man in our head. Mass minus atomic number, 9 minus 4 gives us our neutrons, which is 5. Okay? And now, it also has, we know for ape, that if it has 4 protons, it has 4 electrons. So let's draw our electron cloud now. 1, 2. We're going to need 2 orbitals. Remember, we have ape, or we have 2, 8, 8. Meaning, the first 2 electrons that there are go in the first orbital. Okay? And remember that beryllium has 4. So we have to do 2 more. Next orbital. Doesn't matter where they go. You can place them anywhere. For a total of 4 electrons. How many valence electrons are there? 2, because you count the electrons in the outer orbital. And the valence electrons tell you what group it's in. It's that easy. So there are 8 important groups on the periodic table. Some of them have names, in fact. This one is the alkali metals, group 1. Alkali earth metals, group 2. Group 8 is our noble gases. And those are just a few of the important groups. They call group 4 the carbon group. So yeah, some of these groups have names. Just like families, we have family names. Mine's Camacho, yours is whatever it is. These groups are really, really important. They give us a lot of information. They tell us an atom's reactivity, because notice, and I'm sure you've already figured this out, a lot of these things combine to make stuff. H2O, hydrogen, 2 hydrogen, 1 oxygen, that gives us water molecule, and those combine together to make that. So these elements will group together based on their reactivities, and their reactivity is found based on their valence electrons. So more information to come on this. Just wanted to give you a little information today to catch up, maybe fill some gaps. At this point, you should have a pretty good understanding of 8.5a, which is right here. Wait for it, wait for it, wait for it. Describe the structure of atoms, including masses, charges, and locations of protons and neutrons in the nucleus and electrons in the electron cloud. And there is one other thing I wanted to talk about that, and that is this. We're talking about charges. So if you're looking at your periodic table and you're seeing these elements, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, you might be asking yourself, self, what is the charge of the nucleus of those atoms? I have an easy way for you to remember. So all you have to do is identify the protons. So if you're looking at, let's look at fluorine on the periodic table, number 9, group 7, that group's name is the halogens. You can see that it is number 9, meaning it has 9 protons. And so you should already know your charges of your subatomic particles. Protons are positive, electrons are negative, and neutrons are neutral. So in the subatomic nuclei, there are 2 different types of particles, protons and neutrons. There's only one of those that has a charge, because neutrons are neutral, also meaning no charge. So what that means is, since they do not provide a charge, the protons do, so all nuclei are positively charged. So, to finalize that, fluorine, F, the ape, is 9. Okay? So it has 9 protons. The charge of the nucleus of fluorine is plus 9. Positive 9. All charges of nucleus are positive. And that is it, my friends. And that wraps up 8.5a review and 8.5b, which is atomic identity. We'll see y'all very soon. Ciao.